Hello, welcome to Easy as Pie with Mr. Carpenter. Hello, welcome to Easy as Pie with Mr. Carpenter. I'm Mr. Carpenter, and today we're going to take a quick look at the dreaded inverse function, which my Algebra 2 kids have shown great disinterest in. Right, just a brief overview of what my inverse function does. Let's say I have a regular function with inputs x and then outputs y, and let me make a table here. Let's say the input 1 goes to output 5, 2 goes to 6, and 3 goes to 7, and 4 goes to 8. Okay. Now in a function, right, I put in the input, and that corresponds to some output after I apply some rule to it. Right? So hopefully you kind of figured out that we're taking the input and we're adding 4 to it. Right? So 1 plus 4 is 5. So the input of 1 results in the output of 5. Okay? But you didn't come here to find out what a regular function does. You came here to find out what an inverse function does. And an inverse function is kind of like the antithesis of a regular function, right? My outputs correspond to my inputs. So if I were just to do function notation, f of 2, right, that would mean what would happen if I plugged in 2 for x? What output would I get? Well, I would get 6, right, because the output for 2 is 6. But if I found f inverse of 6, right, people get very scared by this. That's just my notation for an inverse function. If I wanted to know f inverse of 6, I'm asking the backwards question. If the output was 6, what number would I input to get that output? And that would be 2. So notice how these two are opposites of each other. The inputs become the outputs, and the outputs become the inputs. And a very popular question on the Regents will give you a function such as 4x plus 5, and it will ask you to determine what the inverse function is. So how do you go about doing that? Well, first of all, students tend to have a very tough time working with the variable f of x, because it just doesn't really sit right in your mind looking at f of x and seeing it as one variable when there's two letters that look like they're being multiplied, right? We use f of x for a reason, for function notation. But when it comes to manipulating variables, it's not really built for that kind of stuff. So knowing that f of x and y are interchangeable, right? Y equals 4x plus 5 kind of gives off the same vibe, and it's how it looks in your graphing calculator. Let's just take one step and just rewrite that as a y. Right? Because that y looks a lot more nice and humble than the f of x does. Now, if I'm going to find my inverse function, what I have to do is I have to find some way to make it so that my outputs become my inputs and my inputs become my outputs, right? And so just like we saw in that example before, it's almost as if my variables kind of switch places, switch jobs. So let me switch out my y for an x, and let me switch out my x for a y. Hopefully you saw the switch there. I'm going to swap out x and y for each other. They're going to change places. And now I'm going to solve for y, right? Because y just went from a spot where it was by itself to a spot where it's not by itself. So I'm going to take some time and get it back isolated on one side of the equation. And to do that, we're going to do what we know and love in equation solving, right? I want y to be by itself, but it's being added to 5. So I will take away 5 from both sides. So I'm going to have x minus 5 equals 4y. I want y by itself, but it's being multiplied by 4. So I'm going to do the opposite of multiplying by 4, which is dividing by 4. And now I have y equals x minus 5 divided by 4. And now, and only now, do I take that y and replace it with my f inverse of x, right? Because this function that I just found is my inverse function. It's what happened when I swapped out my outputs for my inputs and I swapped out my inputs for my outputs. So this x minus 5 divided by 4, that is my inverse function by definition. So I write it as such, and I am done. Now you can take this logic, and you can apply this to any kind of function. Just for a little more complicated of an example, let's try a quadratic. So let's make f of x equal to x plus 2 squared minus 5. And let's find f inverse of x once again. Once again, f of x is the same thing as y. Let's just turn it to a more familiar variable for a moment. And if I want my inverse function, then I'm going to have to swap out my variable. So my y, I'll change it to an x. And my x, I will change to a y. Now is my job to get y by itself. How do I do that? Well, this square is now a different kind of problem, right? The opposite of squaring is the square root. But a lot of people will make a mistake of just taking the square root of that and taking the square root of that and forgetting about this negative 5 here, which they'll fix by taking the square root of here. And then not only is that incorrect and the equation is no longer in balance, you're just running into trouble by making more mistakes, and you're making your life more complicated. So as a general rule, let's hold off on taking the square root until the base of our exponent is all by itself in the equation. So in this case, the base of that exponent is this entire stuff in the parentheses, right? Because it's that quantity that's being squared. So until the parentheses is by itself, I'm going to avoid my square root. How can I get the base by itself? Well, here's a minus 5 in the way. I'm going to fix that by adding 5 to both sides. Those cancel out. I have x plus 5 equals y plus 2 squared. And now the base of my exponent is by itself. So I have the freedom to take the square root of both sides. Not forgetting about anything. Everything must go into one of the square roots, right? And when I do that, if I square something and take the square root of it, I go back to where I started. So the square and the square root will cancel out, and I'm left with what was in my parentheses, y plus 2. And then over here, I newly have the square root of x plus 5. And now there's only one step left. I want y by itself, but it's being added to 2, so I will subtract 2 from both sides. So I have the square root of x plus 5 minus 2. A lot of people will mistakenly do 5 minus 2 is 3 and go x plus 3 square root. That's a mistake, right? That minus 2 is not invited to the party, right? It can't just barge its way into the square root ahead of time, right? So the square root of x plus 5, and then the minus 2 kind of has to sit outside, is equal to y. And look at that. What have I found here? I have found my inverse function because I swapped out my variables and I solved for y. So I know that the square root of x plus 5 minus 2 is my inverse function, and I am done. Okay. That is inverse functions. Please let me know if you have any questions. I hope this was helpful to you, and have a great day.